multiplying fractions, right? So we are kind of working through a pink, yellow, purple level, following the process to just multiply any two fractions together. That's sort of pink level, yellow level. You can also simplify fractions after you multiply them, or maybe not after, as we're going to learn today. Purple level is simplifying complex fractions before multiplying to make the calculation easier. That's kind of what we're going to learn today. So let's have a wee run through of what we did yesterday. So when multiplying fractions together, as we learned yesterday, it's much simpler than addition. All we have to do is multiply the numerators together and multiply the denominators together. So if the first one here is 1/4 times 1/5, all I would need to do is do 1 times 1 on the top over 4 times 5 in the bottom. So 1 times 1 is 1, 4 times 5 is 20. Okay, you don't need to copy these down. This is me just going over this. So 1 over 20, and that's fine. What we needed to remember to do is to simplify any fraction after we've done the multiplication. So in this one, for example, 5 times 2 is 10, 4 times 5 is 20, but we know that we don't leave a fraction when it can be simplified. These are both in the 10 times table, so we would divide by 10 to give me 1/2. Okay, and I saw a lot of good examples of simplifying from your working yesterday, so well done with that. Okay, right, so today we're going to learn a wee process that we can use when multiplying fractions that can make quite a difficult calculation turn out to be really simple. So for example, if I give you this fraction, 44 over 15, and I'm multiplying that by 30 over 22. Now, doing it the method up till now, we would have to do 44 times 30 on the top and 15 times 22 on the bottom. And we'd probably start panicking and maybe start crying a wee bit. So, but don't worry, there is a really simple method that we can use that can make this a lot simpler. So I'm going to talk about it now. So the trick is, when we are multiplying fractions, and I do want to stress this is only for when we are multiplying. Again, you don't need to copy this down, just watch me as I do it. So when multiplying fractions, we can simplify the fractions before we do the multiplication. Okay, how do we do this? We look at the diagonally opposite numbers. So bottom left, top right, top left, bottom right. And if they can be divided by a common factor, we can divide those by a common factor. And then all we have to do is multiply the simplified numerators and denominators. So that might be quite difficult to picture in your head, so let me show you. I do want you to copy these three down now. Okay, so write these three down, and this is from multiplication. So these three I do want you to write down, and I want to show you the trick just now. So the first one is 1 over 5 times 5 over 7. Now up to now we would just do 1 times 5 on the top, 5 times 7 on the bottom. But what we're saying here is that if I look at my diagonally opposite numbers, so if I just highlight some of this, so if I look at my diagonally opposite numbers, so bottom left and top right, and top left and bottom right. Now what we're saying is if either of those pairs can be divided by a common factor, then we can do it when we're multiplying before actually doing the multiplication, and it will simplify the calculation. So 1 and 7 can obviously not be simplified, but 5 and 5 are both in the 5 times table, obviously. So what I can actually do is I can actually divide both of those by 5 to make the numbers simpler. So 5 divided by 5, we cross that out and we write a 1. 5 divided by 5, we cross that out and we write a 1. So now what this allows us to do is, rather than doing a simplification at the end, we've actually done it at the beginning. So we don't have to worry about simplifying at the end. So all we have to do is multiply whatever the remaining numbers are left. So it's still 1 times 1 on the top, and it's became 1 times 7 on the bottom, which is a hell of a lot easier because that just becomes 1 over 7. And that's your final answer. Now if you'd done it the original way, you would have got 1 times 5 is 5 over 5 times 7, 35. 5 over 35, which you could have divided by 5 to give you 1 over 7. So this is just a way of doing the simplification first rather than at the end. And you'll catch up. So the next example, write this down, is 9 over 14 times 7 over 12. Now we're not going to just go straight to multiplying the top and the bottom. We're going to look at the corners and see can we divide the corners by a common factor. I want you to tell me in the chat, please. I'm going to highlight one of the pairs, so I'm going to highlight these. Tell me what I can divide those by. Go, write it in the chat. Yeah, absolutely right. They're both in the 3 times table, aren't they? They're both in the 3 times table. So what I can do is I can divide both of them by 3 and it will simplify. So 9 divided by 3, we cross out the 9, and 9 divided by 3 is 3. 12 divided by 3, we cross out the 12 and that turns into a 4. So already we've made it a lot simpler, but let's see if we can make it even more simple. Now 7 and 14, they are definitely both in the 7 times table, aren't they? So what I can do is I can cross out both of these. So 14 divided by 7, cross out the 14. 14 divided by 7 is 2. 7 divided by 7, that's going to be 1. So now all I actually have to do is multiply the numbers that are left, and that's me done my calculation. So what's left on the top? 3 times 1 over 2 times 4. So that just becomes 3 times 1 is 3, 2 times 4 is 8, and this difficult looking thing actually turns simply into 3 over 8. Okay, and now here I've brought in that really difficult looking one to show you that it's not really difficult at all. Look at the pairs. So I've got 44 over 15 times 30 over 22. So remember, it's always the diagonals that you're simplifying. So don't try and simplify like 44 and 30 by dividing by 2. That's not what you do. It's only the diagonals. So in your kind of examples, it might be worth kind of color coordinating them or something. It's only the diagonals that we can simplify. So what can we do? Well, 15 and 30, I can see straight away that they're in the 5 times table, but you can go even higher than that. They're also in the 15 times table, right? 15 times 2 is 30, so I can divide both these by 15. So 15 divided by 1 is 1, 30 divided by 15 is 2. All right? Now 44 and 22, again, they're both even, so they will divide by 2, but actually they're both in the 22 times table, because 44 is just 22 doubled, isn't it? So actually I could divide them both by 22. Well, 22 divided by 22 is 1. 44 divided by 22 is just 2. So that really tough looking thing turns into just 2 times 2 over 1 times 1, which is actually just 4 over 1, which is 4. Anytime you have a number over 1, you never write the over 1, you just write it as the whole number on the top. Okay, so that's just a wee trick that I've shown you for multiplying that is going to make your lives a lot easier with some of these. Now we're going to run through some more examples, and what I encourage you to do is just look for opportunities where you can use that trick. You might not be able to use it at all in some of them. Maybe you'll be able to use it with one pair, and some of them maybe both pairs. So just always be on the lookout for opportunities where you can simplify first. And I want to stress, and please can you write this underneath, that this is for multiplication only, right? Do not use this when you try and add and subtract. This trick is for multiplication only. All right, so gonna run through a fair few examples here, and then I'm gonna get you to try some and let you crack on a bit with your own work. Okay, so next page is I've got some examples for you. So down the left hand side, I want you to copy the examples and we're going to do them together. So I have a few here, I've got about 5 or 6. So we're we're thinking about everything you've learned over yesterday and this morning, and you're just trying to make your life as easy as possible. If you can cancel out diagonals, do it. If not, then we're just doing the same method as yesterday, just multiplying the top and multiplying the bottom. Okay, so the first one is 1/5 times 1/8. Okay, we're just going to bash these out. Now, I see it's a multiplication, so straight away in my head, I'm thinking diagonals. Is there anything I can simplify? Well, that's a 1 and an 8, so no. That's a 1 and a 5, so no. So it's actually just 1 times 1 is 1, 5 times 8 is 40. So there's nothing more to do there. Okay, 1/5 times 3/8. Right, we've changed the numerator on the top, so does that simplify with the 5 this time? Well, no, it's actually not, because there's no 5 isn't in the 3 times table. So again, it's just multiplying the top. 1 times 3 is 3. And multiplying the bottom, 5 times 8 is 40. Question C, 1/5 times 5/8. We've changed that to a 5 now. Haha, we see that we have a diagonal pair that do have a common factor. They clearly have a common factor of 5, don't they? So I can do that straight away, as I can divide both of these by 5, turning them into 1s, and then this thing becomes simpler. So it's 1 times 1 is 1, over 1 times 8 is 8. Okay, if you didn't do that simplification, you would have got 5 over 40, which you would have then simplified to 1/8. But it's to save you having to remember to simplify at the end. Many more mistakes are made by people not simplifying properly at the end, so it's much better to do it at the start. Okay, I've got a few more here, as you can see. So making the numbers a bit bigger, and then I've got a mixed number one to show you. Okay, so for purple level people, I'm wanting you to push you on to mixed number multiplication today. So 1 over 19 times 19 over 8. Now, again, if we were doing it the yesterday's way, we would have to do 19 times 8 in the bottom. I don't want to do that. I can see that my corners, I can divide by 19, so I'm going to do that. So both of these are going to turn into 1s again by dividing by 19. So that actually is 1 times 1 is 1 over 1 times 8 is 8. So you can see it's the same answer as the one on top. So actually, if we interchanged bottom left and top right for any two numbers that were the same, it would always give us 1 over 8, because they're always going to cancel out. Okay, now bringing in a whole number times a fraction, so 19 times 19 over 38. Now, yesterday in the video, you were told to change a whole number into 19 over 1. So you've got a fraction times a fraction. Now we can see, right, bottom left and top right aren't going to cancel this time. However, 19 and 38, they're both in the 19 times table. 38 is just 19 doubled. So actually, I can just simplify the top left and bottom right by dividing by 19. So that's going to be 1, and 38 divided by 19 is going to be 2. So on the top, it's 1 times 19, which is 19. And on the bottom, it's 1 times 2, which is just 2. Okay, and the last one just has one extra step, which is changing it to a top-heavy fraction first. Okay, so write out this mixed fraction, please. 2.5 times 1 3/5. You have to change to top-heavy first, so maybe worth writing a wee note there. You have to change to improper first. Top-heavy fraction, improper first. Okay. So anytime you see a mixed number, that's why I was telling you to do it anyway when we're adding and subtracting. Technically with adding and subtracting, we looked at a method. You didn't have to, but when you're multiplying, you absolutely do have to. It doesn't work if you try and kind of multiply the 2 times 1 and then multiply a half times 3. It doesn't work that at all. So we have to change to improper fractions first. So we're pretty good at that, I think. So remember, the denominators are going to stay the same. So I write those in first. The numerators come from this little trick. 2 times 2 is 4, plus 1 is 5. 15 times 1 is 15, and 3 is 18. Okay, now I'm looking for opportunities to make my life easier, to cancel out these diagonals before doing the multiplication. 2 and 18 are both even numbers. They can be divided by 2, can't they? So 2 divided by 2 is 1. 18 divided by 2 is 9. And the last bit is to do, these can be divided by 5. So 5 divided by 5 is going to be 1. 15 divided by 5 is going to be 3. Okay, so this is going to become 1 times 9, which is 1 times 9 is 9. over 1 times 3, which is 3. What is 9 divided by 3? Well, that actually turns into a whole number, doesn't it? So that would turn into 3 over 1, which is just 3. Okay, so quite a few examples to run through there. So we're always looking for that opportunity to cancel the diagonals if we can. I'm going to give you 5 minutes or so to try these for yourself now. Okay, I'm going to need to move them about a bit so you can see them all. So bear with me a second. Okay, your turn now. I've got 6 here, very similar to the 6 we've just copied down. So can you do these 6 now? Go. Gonna do them yourself and then we'll quickly go over them and then we'll let you crack on yourselves. Okay, so give you 3 or 4 minutes to try and do these. Shouldn't take you long. Right, so let's go back to these. I'll need to shuffle these about a bit again, move these down. Just bear with me. Right, so a quarter times 1/7. So there's nothing to cancel there because there's no diagonals that have a common factor. So it's just 1 times 1 is 1, 4 times 7 is 28, 1 over 28, done. 1/4 times 3/7. You're looking at the diagonal corners. Can I simplify anything by dividing? No, I can't. So it's just 1 times 3 is 3 over 28. Okay. Continuing on, 1/4 times 4/7. So this was quite like question C here. Suddenly we do have a diagonal pair that can be divided by a common factor. That common factor is 4. So we're going to divide those by 4. So it's 1 times 1 is 1 over, it becomes 1 times 7. So that's just 1/7. Similar story here. The diagonals are 13s. So we can divide those both by 13 to go 1 and 1. And that's just becomes 1 times 1 over 1 times 7. It's a 7th again. Okay, and then the last two, remember the whole number we turn into 13 over 1. Now the top left and bottom right diagonal can be divided. Now less obvious this time, but 52 is actually in the 13 times table. It's 13 times 4. So well done if you saw that. So we can divide these both by 13. That turns to 1, that turns to 4. So it's 1 times 13 on the top over 1 times 4. And the last one, that's F. Change it to improper fractions first, then do your simplification, then your multiplication. So remember, the denominators always stay the same, so write them in first. When you're doing the conversion, 3 times 2 is 6, add 1 is 7. 14 times 1 is 14, add 4 is 18. Now we're looking for things that cancel. Well, 7 and 14 straight away, I can see they both divide by 7. So that turns into 1, that turns into 2. 3 and 18 are both in the 3 times table, so that turns into 1, that turns into 6. So this now becomes 1 times 6 over 1 times 2. 6 over 2 actually turns out to be that same answer down below. 6 divided by 2, that is 3. Put your hand up if you say you did well on those questions that you tried yourself. Okay, that's good. So people that were here mostly have done well, so that's great stuff. Right, I'm gonna stop it there then, and I'm gonna let you crack on with the work for yourself.